Okay, today guys we're going to learn the sine law. Now the sine law is something that you've done in grade 10. So it should be a review. However, we are adding something new to it that you haven't learned in the sine law. So this first part of the lesson is going to be a review, and then we're going to do an investigation, and then we're going to get that investigation will help us determine the new part of the lesson or the new part of the sine law that you haven't learned. Okay, so let's recap the sine law. So, the sine law. So far in our study of trigonometry, we have been restricted in solving triangles containing a right angle. However, we know that not all triangles are right angle triangles, and the primary trigonometric ratio, SOHCAHTOA, would not be able to calculate our missing side lengths or angles, okay, for non-right angle triangles. Sorry, non-right angle triangles. Now, a triangle without a right angle, okay, is called an oblique. Okay, it's called an oblique triangle, okay, when it does not have a right angle triangle. In this instance, whenever we have an oblique triangle or a triangle that's not right angle, we can use the sine law. Okay, so the sine law, there's two equations. Now it doesn't matter which one you use, okay? So there is, when you have sine of angle A over side A, which is equal to sine of angle B over side B. Okay, we usually use this when we're looking for angles. Okay, or we have side A, okay, over sine of angle A, which is equal to side B over the sine of angle B. And this is usually used when you're looking for sides. Okay, so again, it doesn't really matter though which one you use, because these are ratios. However you set them up, you would have 3 out of the 4 pieces of information and only one variable missing. Therefore, you can always rearrange to solve. So it doesn't matter which one you used. You could still use this to find angles, and you could still use this to find sides. It doesn't really matter, okay? So as long as you know one of them, or as long as you know how to set up the ratio, you'll be fine. Now, to solve a triangle, okay, means to find all missing sides. So anytime you see solve, okay, this means you must find all missing measures. Okay, that means all sides and all angles that are missing. Okay, all sides and all angles. Now we use a sine law, when we use a sine law, we need to know two things. Okay, either you need to know two sides and one angle, okay, that is across from the known side. So we say side, angle, okay, two sides and one angle, or two angles and any side. Angle, side, okay? What I like to say for you to recognize when you can use a sine law is, as long as you have a one side angle pair, okay? One side angle pair, okay? And a side angle pair is when you have an angle, okay, and its opposite side. So the side directly opposite the angle is the side angle pair. Okay, we're going to do an example of this. Okay, let's move on. So, example number 1. Okay, two cabins, A and B, are on either side of a small lake. Okay, here's cabin A, here's cabin B. Now, to find out how far apart they are, Alex walks 500 meters from point cabin A to cabin C. Another cabin located at cabin B is on the other side, okay, let's just say other side of the lake. Okay, using a clinometer, Alex measures that the angle, this is repeated twice, that the angle from cabin A, okay, to cabin B is 52 degrees. So angle from cabin A to cabin B is 52 degrees, and the angle from cabin C to cabin B is 72 degrees. Which cabin is closest to cabin B, and by how much? Round answers to the nearest meter. This is important, okay? So we need to know, is cabin A closer to cabin B, okay, or is cabin C closer to cabin B? So what we need to know is we need to know the distance from A to B and the distance from C to B. So in this case, we need to solve for side C because we always label our sides opposite of the angle. So this is angle C, therefore this is called side C. This is angle A, and the opposite side to angle A is this right here, which is side A. Now, when you take a look at this, okay, you have two angles and a side. You have angle, angle, side, okay? So when you have an angle, angle, side, that means you can use the sine law, okay? Simply because, well, with the information given, do I have a side angle pair? Well, I have this angle, but not the side pair. Okay, I have to solve for that. I have this angle, but not this side pair. I need to solve for that. But I do have this side, and this would be the angle pair to this side. Okay, so this would be the angle pair to this side. So I can actually calculate this angle because a triangle is, okay, 180 degrees. So angle B is equal to 180 minus 52 minus 72, okay, which is 56 degrees. That's angle B. So I know that angle B is 56 degrees, okay? So therefore now I have a side angle pair. So now I can set up my ratio for the sine law to solve for the missing sides. So I can set up, whoops, if I want to solve for side A, so I have side A over sine of A, okay, which is equal to side B over sine of angle B. Now, side A I don't have, but I have my angle A, so side A over sine of 52 is equal to side B, which is 500, over sine of angle B, which is 56. Now, I need to solve for A. That is the variable I need to solve for. So therefore, if I brought this over to this side, okay, this is division. When I bring it over, it becomes multiplication. So I can bring sine of 52 over to this side and multiply it to 500 over sine of 56. So now when I go ahead and calculate that, I have 475 meters. So side A is now 475 meters. Now I can go ahead and solve for side C. So remember, now side C is equal to sine of angle C, and that's equal to, or sorry, sine C over sine of angle C is equal to side B over sine of angle B. Now, why did I use B and not A? The simple reason is you always want to use what's given to you already. Because they gave you this, and this calculation, you shouldn't have an error because you know that a triangle is 180 degrees, so you should know that this is 56 degrees. Because this is information given to you, that's what you want to use to help you find the missing side, okay? Always use what's given to you to help you, okay? So, side C over sine of 72 is equal to 500 over sine of 56, which again, I need to solve for this C, so I have C on its own on this side. I bring sine 72 over, and in that case, it is multiplication. So C is equal to sine of 72 multiplied by 500 over sine of 56. So therefore, when you calculate that, you should get 574 meters. So side C is 574. Now, this is meters and this is meters. Now, which cabin is closer? Well, if I take a look at my diagram, I can see that cabin C is actually closer, okay? Don't get confused by looking at these. This is saying side C and this is side A, okay? But side A represents the distance from cabin A to B, okay? And side C represents, sorry, opposite. Side A represents the distance of cabin C to B, and side C represents the distance from cabin A to B. So, always, whenever you're given this, write them on your diagram to help you identify what the measurement coincides with, so you can do your therefore statement properly and you don't get mixed up, okay? So in this case, well, cabin C, okay, is closer. So therefore, okay, cabin C is closer, and we can say that it's closer by, well, if we go ahead and do the calculation, we want to determine how much it's closer by. 574 minus 475, that's 99 meters, so it's closer by 99 meters, okay? And there you go, we've used the sine law. This should be all review for you to solve this word problem, okay? This is a grade 10 problem taken out of a grade 10 textbook, okay? Now, this is your sine law review. Now we're going to move on to the new stuff. So, we're going to do an investigation. Now, for this investigation, okay, it asks you to draw these triangles on a separate sheet of paper. Don't worry about that. From here, I just want you to follow along, but I do want you to fill this information in as we fill it in, okay? But for all the triangles that I'm going to draw, just follow along to understand, okay? So, remember, you can use a sine law when you know two side lengths, okay, of a triangle and the measure of an angle opposite one of the sides, okay? So you can use sine law anytime this happens. In this situation, okay, does the given information always define one unique triangle? So when you have two sides and one angle, are you always going to create one triangle? Well, we need to figure this out. As according to grade 10, apparently yes, but not necessarily, okay? So complete the following steps to determine the answer. Draw a line segment AB that is 15 centimeters long. We're going to do this, okay? Construct a line segment AC, okay? So that angle CAB is 40 degrees, so this is 40 degrees. And side B, so since this is angle B, opposite must be side B, is 10 centimeters, okay? Draw it to scale on another piece of paper. So we're actually going to do that. I did that right here for you, okay? So here we have our triangle. This is exactly 50 centimeters, okay? So I have this, sorry, 15 centimeters. There you go. I can measure it for you. That is 15 centimeters. This is 40, and that's degrees, sorry, and this is exactly 10 centimeters, okay? So let's go back. Now, construct an arc that originates from point C with a radius of 2 centimeters as shown above. Does it intersect AB? So, let's do that right now. So, I'm going to use this right here. This is called the compass. Okay, this has to be 2 centimeters. It has to be opened up to 2 centimeters. So I'm going to measure it. Okay, and I have it measured to exactly 2 centimeters. So I'm going to take this and I'm going to place it on point C. Okay, and as I place it on point C, I will draw, okay, an arc that's happening. Now, when you see this, okay, let's answer the question. Oops, sorry. Going back. Now, does it intersect AB? So does this line, okay, will it intersect AB? Now, intersect meaning it has to intersect, it has to touch this line, AB. Does it touch that line? Well, no, it doesn't, right? It doesn't reach line AB, which is at the bottom. Okay, so we will write that it does not. Okay, now we are going to repeat steps 2 using the radii from the table. So we're going to do the exact same thing we just did where we had a radius of 2 centimeters, and the number of triangles that can be drawn in this case is 0 because this arc, okay, did not touch line AB. In order to create a triangle, okay, this piece must touch somewhere along this line to create a triangle. So we're going to do this now with 4 centimeters, 6 centimeters, 8 centimeters, and 10 centimeters. So let's go ahead and go to 4 centimeters. Now at 4 centimeters, I'm going to do the same thing. I'm going to take my compass, I'm going to measure it to 4 centimeters. It is 4 centimeters right there. Now I'm going to place the compass on point C. Okay. And now that it's on point C, I'm going to draw. Okay, does this radius, okay, of 4 centimeters, does this actually touch AB? Again, no, it doesn't. So we can go back, and this is where you're filling this in. So number of triangles that can be drawn, well, again, 0. You have no triangles, okay? Simply because this arch, okay, this radius, which is 4 centimeters, does not intersect with line AB. Let's move on to the next one. A radius of 6 centimeters. Again, I'm going to take my compass. I'm going to measure it out to 6 centimeters. Okay, 6 centimeters is right there. Perfect. Now I'm going to place this on my, whoops, let me place this on here. Okay, place it on point C, and I'm going to see if it will touch, and no. In fact, this radius, which is 6 centimeters, does not, okay, intersect side AB. So we'll go all the way back to our chart, and it creates, again, number of triangles that can be drawn are 0. Now we're going to go into 8 centimeters. Okay, so let's go to our radius of 8 centimeters. Now, oops, let me just undo that. 8 centimeters, I'm going to take my compass, and my compass is at 8 centimeters right there. When I bring this up to my point C, okay, I will go ahead and draw, and you can see that yes, this does intersect line AB, and it actually intersects it at 2 specific points. It intersects here as well as here. Okay, so now how many triangles does this create? Now don't remember, this is the same line. Okay, this right here is not creating a triangle. Don't think that the green, the red, and the black is a triangle, because this is the same line just being swung over. Okay, so this line, okay, was swung to here and hits here. Okay, therefore you have one triangle, which is right here. Actually, let me make this thicker. One triangle from here. Actually, let me use red, sorry, since that was red. Okay, one triangle from here to here to here. Okay, that's one triangle. And you also have another triangle, okay, that is from here to here to here. So you actually have 2 different triangles. You have one triangle that is like this, okay, A, C, okay, and this is still considered B, okay, if this is a triangle, then you also have this triangle right here, okay, which is A, B, and C. Now, there are some things that you have to understand here. Now, this angle, okay, is 40 degrees. That's angle A, okay, and the angles, okay, let me just get another color here. This angle here and this angle here are actually the same, okay, because I know I said this is not a triangle that you're going to use, but you can use this as part of a solution. It is not one of the triangles we are identifying, but it is, you can use it to help you solve angles, okay? So these two angles would be the same because this right here would be an isosceles triangle, and in an isosceles triangle you have two angles that are the same because you have two sides that are the same, okay? Now, this angle, okay, here, between here, oops, let's use a different color, between here and here, okay, these are supplementary. Okay, supplementary, what does that mean? It adds up to 180 degrees. Okay, now this is called, okay, B1, okay, B1, and this is called B2, or you can use the other way around, B1 and B2, okay? So B1, I'll do that up here, plus B2 is actually equal to 180, simply because, okay, that's why they're supplementary. Simply because if this is B2, okay, which is technically, sorry, I wrote these, this should be C and this should be B. I apologize. If this is B2, okay, and this is B1, think, well, this angle is this right here, and this angle, which is B1, is this right here. So if I know, okay, what this angle is, I can actually solve for this angle by subtracting it by 180. Okay, so if I know B1, I can solve for B2 because I know that B2 and the angle here, which is technically here, okay, are the same angles. Okay, that's something you have to remember. This is important when it comes to solving, okay, mainly for solving for word problems. So now let's go back, okay, and let's go to our chart and let's fill this in. For a radius of 8, okay, we actually have two triangles, okay, and we actually have one that's an acute triangle and one that's an obtuse triangle. Okay, so let's go back to take a look at that again. So we have one acute triangle, which is this in red. Okay, the big one in red is an acute triangle, and this green one is obtuse because you have an obtuse angle. This is an obtuse angle. This is greater than 90 degrees. The red one, you will not have angles greater than 90 degrees. That's why this is called your acute, okay, triangle, and this is called your obtuse triangle. Okay, this is all posted on Edmodo for you guys. Okay, now let's look at a radius of 10 centimeters. So now 10 centimeters, this compass right over here actually doesn't stretch out, guys, to 10 centimeters, but 10 centimeters, okay, is the same size as the opposite side, as this side. Therefore, because it's the same, you know that it's going to be an isosceles, and in this case, this will only intersect one time. So if I swung the radius of 10 centimeters over, it will only hit right here in this corner, okay? This is the only place it'll hit, so therefore you will only get one triangle, okay? And it's an isosceles triangle. So let's go back and fill this into our table. So for 10 centimeter radius, we have one isosceles, one isosceles triangle. So we did our investigation. Now, determine the radius that would allow you to draw exactly one triangle. So if I have this set up, okay, a radius that would allow me to draw exactly one triangle. This is actually supposed to say one right triangle. So the radius that would allow me to draw one right angle triangle, well, if I take this, I can measure a right angle triangle is a straight line from one vertex down forming 90 degrees, okay? And in this case, it is about, you can measure it to about approximately 6.5 centimeters, roughly, okay? So let's fill that into our chart. Okay, so approximately, okay, 6.5 centimeters to get one right angle triangle. This should say exactly one right triangle. Okay? Now, this says state the value of B sine A. What does this represent? What this is saying is side B multiplied by the sine of angle A. So let's go back to our triangle. Side B is 10 centimeters. Angle A is 40 centimeters. Okay, so just plug this in. So B sine A, this is 10 times sine of 40 degrees. And in this case, you should get 6.4279. What does this represent in your diagram? Well, what number is this close to? This is close to this right here, okay? If that's close to this, what did this represent in our diagram? Well, this actually represented, when I drew that straight line, okay, to come up with a right angle triangle, that is actually my height of my triangle, okay? So this is, remember my triangle was like this, okay? And you had the dotted line. This was 40 degrees. This was 10. This right here is your height of the triangle. So therefore, B sine A is my height, okay? So this represents my height, okay, in my diagram. So the height is equal to B sine A, okay? This represents the height of a triangle. Now, why is it the height B sine A? Well, think about this. Remember, this is a right angle triangle, okay? If I want to find this side, using my right angle triangle property, SOHCAHTOA, this side is my opposite side, and I have my hypotenuse. Remember, sine of angle A is equal to opposite over hypotenuse. So sine of 40 is equal to h over 10. If I rearrange this, okay, this would be 10 times sine 40 equals h, which is what we did right here. Remember, this is side B and this is angle A, okay? So anytime you want to find the height of a triangle, you can do B sine of angle A to find the height. Very important. That's something you need to remember. Okay? So now, for which value of A does the arc intersect twice? Well, when A, side A, was equal to 8 centimeters, okay, that's when the arc intersected twice. When A was equal to 8 centimeters, the arc intersects AB twice. So when side A, okay, is greater than my height, but less than side B, I have two triangles. Okay? When side A is greater than my height, so let's go back here. Side A was 8 centimeters. Let's go back to my triangle. If this side A is 8 centimeters, it's greater than my height, which my height we determined was roughly 6.5, okay, or 6.4, so forth, whatever. Side A is greater than my height, but less than side B, okay? That created two triangles. That's very important. This is something you need to remember, okay? And I'm gonna explain why in a minute. Let's move on. So now we're gonna move on to the next page for you guys. So now, remember, okay, the sine law is used in the following cases. When you have two angles and any side, okay, so you have angle, angle, side, or angle, side, angle, two angles and any side, or when you have two sides and an opposite one of them, okay, so you have two sides and an angle that is opposite to one of them, okay, so side, side, angle, two sides and one angle opposite to any of the sides that's given to you. In this case, when you have two sides and an angle, you must check for the ambiguous case. Okay, the ambiguous case. Now, what is the ambiguous case? Well, the ambiguous case is when you can create two triangles from one of the sides measurements, okay? So, the last case, okay, which is when you have two sides and an angle, is called the ambiguous case, because sometimes it is possible to draw more than one triangle for the given information. Now, in this case, there are four possible outcomes if angle A is acute. So take a look at this. I'm scrolling down. If my angle A, this right here, okay, which is the angle that is always opposite the side, okay, that you're looking at, this angle, if this is acute, meaning less than 90, you have four different possibilities, okay? There's four different possibilities, four different outcomes. Now, if there are also two possible outcomes if angle A is right or obtuse. So down here, when angle A, okay, is a right angle or an obtuse angle, meaning it's 90 degrees or greater than 90, you have two possibilities, okay? So, the side opposite, these possibilities are shown for the given angle A. Now, the given sides A and B in triangle A and B is ABC as well, okay? So, this is shown for angle A when you're given two sides and an angle, sides A and B and one of the angles. Now, the side opposite the given angle is always angle A. So anytime you are given an angle, the opposite side is angle A, okay? And B sine A, okay, represents the height, okay? This is the height of the triangle. So B, side B, multiplied by the sine of angle A, that will give you your height. Okay, that's something you must always remember. Now here are the conditions. When your angle A is less than 90 degrees, there is two conditions. Well, first, if side A is less than side B and side A is less than side H, you have no triangles. Okay, so if side A is less than side B and less than your height, you will have no triangle. So in order to determine this, you must calculate the measurement of side A, B, and H. Okay, if it follows this condition, there are no triangles. Now, because side A is too small, like you saw in the investigation, to connect to this side, that's why there's no triangles. Now, if side A is equal, okay, side A is equal to side H, so it's equal to the height, you have one right triangle. Okay, that means side A is your height. So when you calculate for the height, and that is the exact same measurement as side A, you have one one right triangle. Now, if side A is greater than side H, okay, if side A is greater than your height and greater than and less than side B, greater than the height, less than side B. Remember, you read this from the middle to the left, middle to the right. So side A is greater than height but less than side B. You have two triangles, okay? One acute triangle and one obtuse triangle, okay? And don't forget, this angle right here is your B1, and this angle right here is your B2. B1 plus B2 equals 180. So if you were given this angle, you can figure out this angle. If you're given this angle, you can figure out this. The two triangles that you have, one of them that's obtuse, okay, is this triangle right here, A, B, C, and the other triangle is the triangle right here, okay, A, B, C. This is your obtuse, and this is your acute. So you have two possibilities, two possible triangles when side A is greater than your height but less than side B. Now, again, when your angle A is acute, okay, and side A is greater than, okay, or equal to side B, you will have one triangle, okay? Now, when side A is actually equal to side B, you get, as we saw, one isosceles, one isosceles triangle. But if side A is greater than side B, you will get one oblique triangle, okay? So side A is actually the same measurement as B, you're going to have an isosceles triangle, but if side A is greater than B, you have one oblique triangle. These you have to have memorized. You have to have all these conditions memorized because you'll be asked to solve, okay, for missing sides, missing angles, but in the case that you have, okay, your side A greater than your height and less than your side B, that means you have two triangles, and that means you must solve for two different triangles. Okay, we're going to do an example of that. Now, when your angle A is greater than or equal to 90 degrees, okay, you will have an obtuse triangle, and there are two different conditions. Now, this should ring a bell. Anytime angle A, okay, is greater than or equal to 90, you should know automatically that is not the ambiguous case, and you will not have two triangles. Okay, so that should ring a bell that you automatically do not need to solve for two triangles. Anytime angle A is less than 90, then yes, you have to find the height, okay, and then determine if side A is greater than height and less than side B, and then determine if it's the ambiguous case and so forth. So if side A is less than if side A is less than side B, you will have no triangles, okay, no triangles. And if side A is actually greater than side B, you will end up with one obtuse triangle. Now this is important. Determining whether a given angle A is acute or obtuse, okay, and then comparing the size of A, B, and B sine A, which is your height, okay? Comparing A, B, and the height allows you to see which situation you are dealing with, and in turn, the number of possible situations. So, you must compare, okay, you must figure out what angle it is, if it's acute or obtuse, then you must compare the sides A, B, and H to determine what situation out of all of these that you're dealing with. So now let's do some solving. So example 2, solve triangle ABC if angle A is 29.3 degrees, side B is 20.5 centimeters, and side A is 12.8 centimeters. Round the side length to the nearest tenth of a centimeter, okay, and the angles to the nearest degree if necessary. So let's draw this out, okay? So let's go ahead and draw a triangle. Now I know that angle A is 29.3, okay? I'm not going to connect the triangle because I don't know if this will create a triangle, create one triangle, or create two triangles. So I'm not going to draw the triangle fully completed yet, okay? All I know right now is angle A, okay, is 29.3 degrees. Side B is 20.5 centimeters. And side A, so that means this side, is 12.8 centimeters. Okay, this is B and this is C. Now we always label our triangle ABC. Okay, and the angle that they usually are going to give you in any of your homework, okay, is the angle that has to be placed here. They may use different letters. They may use GEF or DEF, any other letters they can use, XYZ. Remember that whatever the angle they're giving you is here, okay? And whatever the side opposite that angle, okay, is the side, this side. Now you can go ahead and relabel everything ABC to help you because all the conditions are based on ABC so you don't get confused. So if they use different letters, you can use ABC instead, okay? So now we must solve this. So in order to solve this, I first have to check if there is an ambiguous case. The reason why I need to check is because I have side, side, and an angle. So as soon as I see side, side, angle, or two sides and an angle, okay, therefore I must check for the ambiguous case. Okay, I must check for the ambiguous case. So now, first thing I check, okay, is I'm going to check and calculate the height. Okay, check / calculate height. Okay, so when I check and calculate the height, remember height is equal to B sine A. So side B is 20.5 times sine of A, which is 29.3. So my height is equal to 10. Now, I have to compare my sides. Step 2, compare sides A, B, and H. So, in this case, side A, is it greater than or less than side B? So 12 centimeters is side A, it's actually less than side B. So side A is less than side B. And is side A greater than the height? Yes, it is. 12.8 is greater than 10, so it is greater than my height. So side A is greater than my height and less than my side B. Therefore, okay, there are in fact two triangles. This creates two triangles. It creates one acute and one obtuse. So because it's saying solve, that means I must find every missing piece of information in this triangle. So now I can go ahead and I can draw my I can draw two triangles. I have one triangle that I know that is my acute triangle. Okay, this is my acute triangle. So this is 29.3 degrees. This is side A. This was 20.5 5. This is angle C. This is 12.8. And this is angle B. So the missing pieces of information, I need side C, angle B, and angle C. Those are the three missing pieces of information that I need to solve for. So now, how do I do that? Well, simple. I have a side angle pair. Side A is 12.8 and angle A is 29.3. So if I have a side angle pair, I can solve for another side or angle depending on what's given to me. Since I have side B, I can solve for angle B using the sine law. So I have sine of A over A, which is equal to sine of B over side B. So sine of A, this is sine of 29.3 over side A, which is 12.8. That's equal to sine of B over side B, which is 20.5. Now I need to solve for angle B, so therefore I must bring 20.5 over sine of 29.3 over 12.8 multiplied by 20.5, and that's equal to sine of B. This gives you, we're going to round this to 4 decimal places because this is not my final answer. So this should give you 0.7838. That's equal to sine of B. Okay. Now this, I need to solve for angle. So when I bring sine over, I'm doing the inverse of sine. Sine, okay, of 0.7838 equals angle B, and this is 51.6 degrees is angle B. Okay, now remember, this is my acute triangle. This is technically B2. So this is, okay, I can write here, angle B2 is 51.6 degrees. So I have my first angle. Now, because I have B2, I have angle A, I can simply solve for angle C because I know a triangle is 180 degrees. Okay, so angle C is equal to 180 degrees minus 51.6 degrees and then minus 29.3 degrees. Okay, so angle C is equal to 99.1 degrees. Okay, now I have angle C. I need to figure out my last piece of information. I need side C. Okay, now the reason why I solve for angle C first is because I need that angle to help me with my side angle pair when I set up the ratio for sine C over C. I need this angle. So now I'm going to set up my ratio. Okay, I'm going to do the sine law again. Side A over sine of angle A. Again, I'm using side A and angle A because that's what's given to me. That's equal to side C over sine of angle C. So this is 12.8 over sine of 29.3, and that's equal to C over sine of 99.1. So this now I want to solve for side C. So 12.8 over sine of 29.3 multiplied by sine of 99.1, and that's equal to C. When I calculate that all, I get 25.8 centimeters. And I solve for one triangle, guys. This is one triangle I solve for. Remember, there are 2 triangles. So now I must solve for my other triangle. So let me just separate everything here. So you see that I'm doing work for the next triangle. Okay, so that's the first triangle. Now my second triangle is my obtuse triangle. So remember, my obtuse triangle is look something like this. Okay, that's my obtuse triangle. Again, I'm still using the letters A. Now this is B1 and C. Side A is still 20.5. Angle A is still 29.3. Side A is still 12.8. Okay? Now, I can calculate B1 without having angle C. How can I calculate B1 without having angle C? Well, remember, B1 plus B2 equals 180. Okay? So I have B2. Therefore, B1 must be equal to 180 minus B2, which is 180 minus 51.6. And we get angle B1 is 128.4 degrees. So we have angle B. Now that I have angle B1, I can solve for angle C. Angle C is equal to 180 minus 128.4 minus 29.3, and that is equal to 22.3 degrees. Okay? Now that I have angle C, so I have angle B, I have angle C. Now I need to solve for side C. Again, we do the same thing with our ratio. Okay, we have A over sine of angle A, which is equal to C over sine of angle C. 12.8 over sine of 29.3, which is equal to C over sine of 22.3. 12.8 over sine of 29.3, and I bring this over, multiplication, sine of 22.3, okay, and that's equal to C. When I do my calculations, I should get 9.9 centimeters. And now I have solved. So because of the ambiguous case, because I had to compare, or I know that I have a side, and an angle, I have to check for the ambiguous case, which means I have to compare side A, side B, and the height. I have to calculate the height. When I did that and I compared them, I saw that there are two triangles. Therefore, that means when I'm solving, I have to find all the missing information for two different triangles. Okay? So, let me just see how much time we have. Okay, we have some more time. Let's go on to our next example. This is our last example, example number 3. Albert and Bell are part of a scientific team studying thunderclouds. The team is about to launch a weather balloon into an active part of a cloud. Albert's rope is 7.8 meters long and makes an angle of 36 degrees with the ground. Bell's rope is 5.9 meters long. How far is Albert from Bell? So we need to first always draw a diagram. So we have Albert, okay, is here, okay, and he has, this is his rope, okay. This right here is going to be the ground, okay. So we know that his rope is 7.8 meters long, okay. And we know that the angle that the rope makes with the ground is 36 degrees. So if this is the rope and this is the ground, the angle it makes is 36 degrees. Now we know that Bell's rope is 5.9 meters long. Now remember, Bell is here, okay? They're both standing on the same ground, okay? Her rope is 5.9 meters long. Now, we're not going to draw it from here, okay? Because we're talking about, we don't know how many triangles it creates. We're going to draw like this, but we're going to stop it because we don't know if these will actually connect or not. So Bell's rope is 5.9 meters long. We want to know how far Albert is from Bell. So we need to figure out this right here. So I'm using the letters A, B. I might as well use A, B, and C. Therefore, I need this right here. I need side C. Okay, that's what I need to do. Now, I can't just go ahead and solve for side C like I did in grade 10 because I have two sides. I have to check first, okay, for the ambiguous case, because again, I have a side-side angle that's given to me. So because I have a side-side angle, I must compare side A with side B and the height. So first, check the height. The height is equal to B sine A. So side B is 7.8 multiplied by sine of angle A, which is 36. So the height in this case is 4.58. Okay, so now side A is 5.9. Okay, side B is 7.8. Is side A greater than or less than side B? Well, side A is actually, okay, 5.9 is actually less than side B. 5.9 is less than 7.8. And is side A greater than or less than the height? Well, 5.9 is greater than my 4.5. So therefore, because side A is greater than the height and less than side B, we have two triangles. Again, we have two triangles, so therefore, again, in this case, there are two answers for triangle C. Remember, one triangle is acute, one triangle is obtuse. Let's start with our acute triangle. Okay. A, B, C, 36 degrees, 7.8 meters, and 5.9 meters. I need this right here. Remember that. So, do I have a side angle pair? Yes, I do. Now, in order to solve for side C, I would also need angle C, which unfortunately I don't have, which means I need to find another angle before I can get angle C to help me get side C. So the only other angle I can get now is angle B, which I can solve for because I have the side that's the pair that goes with angle B. So this is going to be sine of A over side A, which is equal to sine of B over side B. So sine of 36 over 5.9, which is equal to sine of B over 7.8. Okay, I must isolate for B. So sine of 36 over 5.9 multiplied by 7.8 is equal to sine of angle B. When I do that and I round to 4 decimal places because it's not my final answer, 0.7771 is what I get for sine of B. And again, this is technically, guys, B2. Okay? Remember, this is B2. Okay? Because it's this, that property of the triangle. We have two triangles. So now I have to solve for B2. So this is sine inverse of 0.7771. Guys, that means you're using your second function sine button. Okay, so this is actually angle B2 is, you should have 51 degrees. Okay, for angle B2. Now that I have angle B2, I can go ahead and solve for angle C. Angle C is equal to 180 minus 51 minus 36, which angle C is 93 degrees. So now that angle C is 93 degrees, we can go ahead and set up a ratio to solve for side C. A over sine of angle A is equal to C over sine of angle C. A was 5.9 over sine of 36, which is equal to C over sine of 93. Bring this over, 5.9 over sine of 36 multiplied by sine of 93. That's equal to side C. And when you do the calculations, you should get 10 meters. So side C, in this case, is 10 meters. Okay? So make sure you get that all down. Now, let's go back And now let's solve for, because there's two possibilities, let's solve for the obtuse triangle. So my obtuse triangle is something like this. Okay, so again, this is A, B, C, 7.8, 5.9, and 36 degrees. So again, I need to solve for side C, but remember, this is B1. I don't have to go through a bunch of work to find this angle because B1 plus B2 is 180. So again, I can go ahead and solve for B1 because 180 minus B2 is B1. Okay, so 180 minus B2, which we found was 51 degrees, B1 is now 129 degrees. The reason why I needed to find B1, again, I need this angle to help me find angle C, which angle C will help me find side C. So I need to find B1 first, angle B1. Now I can go ahead and find angle C. Okay, so 180 minus 36 minus 129. Angle C will be 15 degrees. Okay, 15 degrees, angle C. Now I can go ahead and set up my ratio. Okay, so my ratio, which is side A over sine A, which is equal to C over sine C. A was 5.9 over sine 36, which is equal to C over sine of 15. Rearrange to isolate for C, so 5.9 over sine of 36 multiplied by sine of 15 equals side C, or sorry, side C. When I do the calculations, I'm left with 2.6 meters. So I have two possible answers. I have 2.6 meters and I have 10 meters. So my final answer would be, therefore, Albert could be 10 meters or 2.6 meters away from Bell. And that's our final answer. Okay? Now for homework, this is it for lesson. I know it was a quite long lesson. For homework, this is all one day. Okay? You are to do all this homework plus the worksheet. Okay? Take your time. Some of it is just a matter of solving two triangles. Okay? Go through the word problems carefully. If you have any questions, you can still ask me on Edmodo. Okay? And your test for this will be on Thursday. Okay? This should be on Thursday, I believe. I will double check with Miss Awad. Possibly could be on Wednesday, but it should be on Thursday. Okay? Alright guys, good luck.